Hey guys, it's Mike from Shop For Me Garage. Today working with World Car Auto Group, and today we're looking at this 2007 Mazda Miata MX-5. Customer states that it has a check engine light, and every once in a while when they start their vehicle, the engine idle just revs really high. It's probably electronical issues. Great. Oh no. Okay, so let's check out these codes and see what we have here. I have the Mazda IDS system hooked up right here, and I can go to these codes, and the first one has to do with intake manifold tuning valve control circuit low, and the other two, and the customer was complaining about the check engine light, is the P0704. Usually you see a P07 code, and that has to do with transmission. In this case, it has to do with the clutch switch input circuit malfunction. Now, whenever we look at what Mazda considers the clutch switch circuit malfunction, is what they're basically saying right here is that it's a clutch pedal position switch input circuit problem. They're calling it a problem. It's not really giving us any information, although in this thing there is a breakdown of detecting conditions and possible causes. And one thing that they say to do is to go into the data list and check and see, look at the clutch pedal position, and I'm looking for a PID called CPP for clutch pedal position, and I actually can't find it. I'm looking through all these PIDs here, and where it should be right up here, and I don't see it. So that puts a little bit of damper just in checking this, doing this diagnostic alone, but there's an easy way to check this out. Obviously, you're pushing the clutch pedal and it's not detecting that the clutch pedal is being pushed. So I got my head up under there earlier, and yeah, there's an issue, and I'll get you under there so you can see what I'm talking about. Okay, so I don't know if you can see this. It's kind of tight under here, but this is the clutch pedal position switch, and if you see it, it looks like it's coming apart right there. Right here, it is definitely has issues. So that alone right there, that's the problem. And this needs a new clutch pedal position switch. There's no doubt about it, and there's no reason to even go any further on the diagnostics. So the easy way is just look at the switch. We could run check circuits, open circuit and all that stuff, but in the end it's going to need one anyway because it's coming apart. So we might as well just put that in and be done with that. Okay, so the other code that we're dealing with is the variable intake air solenoid valve circuit low. It's a low input. So low input a lot of times means like a short to ground, whereas high input would mean open circuit, but not always, depending on how the PCM operates the system. And I can tell you in this case, the low input would mean more of an open circuit. And going through this diagnostics, basically what they want you to do is pull the valve off and perform an inspection on it. And we can do that, and I can show you how to do that. But there's an easy way to check it out. So this is what we're talking about right here. Get this off. This solenoid right here. This is the tuning valve control solenoid. And we can go into the PID data of this for the IMTV is what it's called, and we can actually actuate it. So in this case, and I don't know if you can see that, and it shows that it's on. We can actually actuate the valve. And I'm clicking on it. Okay, it shows that it's turned off. It shows it's turned on and off, and I cannot hear anything clicking. Right. So we could check this circuit. We could use a volt ohm meter and check it. But sometimes in certain circuits, and this is the schematic right here, variable intake air solenoid valve. So it goes through this circuit right here, which is right here, and it has a fuse. So this is coming through the main relay, and if this fuse were bad or anything, this also controls a purge valve, right? It controls the purge valve, and it comes in right here, controls the variable intake air solenoid, which we're looking at, also controls the EGR valve. So if we actually had a bad fuse right here, we would have problems with the EGR valve. We'd have code set for that. We'd have code set for the purge valve, which we don't have. So it's not the fuse coming in, and we could check power, and we're going to check power too. But basically what I'm trying to get across is we have power constantly going all the time as long as this main relay is on. And when the vehicle's key is on or started, it will have power there. And the PCM, powertrain control module, actually grounds this circuit. Okay, so you would think that you could put a voltmeter across this and see if this turns on or off. But in the PCM itself, it has another circuit which it uses to test this circuit, and that will give us a false reading. But if we use a circuit with a load, like this test light, then we can get it to turn on and off. And let me hook this up real quick, and I'll show you what I mean. Okay, so I have these two pins hooked into the back, their back probe. You don't want to stick anything in the front of these connectors, guys, because you open up those connectors and then you're going to give yourself all kinds of issues. So it's always a good idea to back probe. Okay, so I have one going to the front of this test light right here, and the other one is hooked to the ground part of the test light. So now I should be able to go over here and click this thing on and off, and you can see it when I click on. There it is, it's turning on and off, just like that. On, off. So what that does is, rather than going through all this feeling my bob stuff, you know, to diagnose wiring harnesses and all that stuff like that, because you can disconnect the PCM connector and you can ohm out the harnesses, and that's probably what they're going to want you to do. Make sure you don't have any shorts to ground, shorts to power, stuff like that. But just in doing this little test, as long as you have a scanner that can make it, you know, turn on and off like this, then you've pretty much tested everything. You've tested the ability for the PCM to actually run this test. So, and we ran the test, and the circuit's working. We're getting power and ground to it, and it's turning this on, which basically tells me that that solenoid is bad. I have another trick to make it easy to test. So I'll show that to you right now. Right here, I have, now this is from a Mazda 3. This is old solenoids from Mazda 3, and this solenoid is good. This actually happens to be the same sort of solenoid, has the same connector and everything. So rather than running this test, what I can do is plug this in. Right there. And then I can turn it on and off. And I don't know if you can hear that, but it is clicking. So basically, in the end, it just needs a solenoid. So easy test, and we'll get a new solenoid for it. By the way, if you run this test, and I'll show you, I'll go ahead and hook it back up. I'll hook it with a voltmeter, and I'll show you what the test looks like with the voltmeter, because it just won't work like that. You need something with a load. I'll hook that up right now, and I'll show it to you. Okay, so I have the same setup right here, the same back probing in, have the voltmeter hooked up, and I'm gonna cycle this. It's on, off, on, off. And it's just going from like 11.17 volts to 11.8 volts. And that's because this PCM right here actually has a circuit with inside of it that it's always testing. So no matter what, voltage is flowing through into the PCM, and the PCM is determining by that special circuit if it is actually shorted to ground or has an open circuit. And because of that, we cannot test with a tool that doesn't put a load on it. So the light bulb in the test light, it puts a load on it, and we're able to see that. Another thing that Mazda wants you to do right off the bat, which we didn't do, was test that solenoid. Basically, you put power and ground to the solenoid, and you can blow through certain things. So this solenoid right here, it has a it's a it changes, it lets air either flow through it or it doesn't let air flow through it. And this one's got this hose on it right here, right? So you got, you know, air in, air out, you know, and that's it. And of course it's got this one on the back here, which relieves pressure or maybe air out the other way. And what they're going to want you to do is put power and ground to this connector and then see if you can actually blow through it. And with power and ground to it, you should be able to blow through it or not blow through it. And without power and ground, it would be vice versa. And that's it. It's a real easy test just to see if the solenoid's bad or good or whatever. But we pretty much found out that, you know, it's a solenoid, you know. And this right here is why technicians and mechanics are called hoarders. Yeah. This is why this stuff collects. And I've had this for many years. So we're gonna go ahead and get that solenoid replaced and we'll be done with that. We get the clutch switch replaced and we'll get the solenoid replaced, clear the codes, drive it, make sure everything's all right, and we'll do that right now. Well, truth going on and being told, it's been another day, but we got our parts in. Let's get these in real quick. Okay, so a lot of y'all at home and stuff are probably wondering, well, why don't you just check the coil, check the resistance in the coil and see if it's good or not? And yeah, we can do that. Mazda does not have a spec on these, but we can compare it to a known good one. This is not this is a known good one. It's not the brand new one, but we can still compare them. But when you see this, you'll see we didn't even need to compare it. And so I'm gonna go ahead and ohm out the known good one right here. Nope, that ain't it. Let me get in there. Okay, so if you can see my lead's not in the way. Okay, I got 32.6 ohms of resistance. Okay, so that's a known good one. Let's move on to the other one. Check the resistance in this. I can get my leads out of the way here. Okay, so you see, hopefully you can see it, see the meter. Come on. Okay, 24.76 mega ohms. Okay, so that's 24,760,000 ohms. So in the automotive industry, that 24 million ohms, that's an open circuit. Okay, so yeah, you didn't even need to compare it to this one. Just by checking that and seeing that 24 million ohms, that's a bad solenoid right there. So just wanted to show that to you. Well, we got everything in. Got the codes cleared, and she seems to be running fine. Let's take her on the road, see how she performs. So there you go, guys. One more chicken light down. So for Work Hard Auto Group, I'm Mike from Shop Foreman Garage, asking you, when was the last time you tangled with a chicken light? Run her on down in the comments below. Maybe we can address that too. Thanks for watching. Please like and subscribe, and I'll see you next time.